Hi everyone, welcome to Maths video class 6th and we are on chapter 5. We had seen different properties for addition. Now we'll be seeing different properties for subtraction. So first is closure property. If x and y are two whole numbers, then x minus y is not necessarily a whole number. So x is equal to 8, y is 3. X minus y is 8 minus 3 is equal to 5, which is a whole number. Similarly, this you can see x is y is 6. X minus y, 6 minus 6 is 0, which is a whole number. Means when we subtracted two whole numbers, we got whole numbers. But the property says it is not always necessary. That we'll see in the next example. X is 15, y is 18, x minus 5, y is 15 minus 18, which is minus 3. And minus 3 is not a whole number. Similarly, x is 0, y is 12, x minus y is 0 minus 12 is equal to minus 12, which is not a whole number. So, minus 3 and minus 12 is not a whole number. Okay, so in other words, the whole numbers are not closed for subtraction. Next is commutative property. If x and y are two whole numbers, x minus y is not equal to y minus x. If x and y are two whole numbers, then x minus y is not equal to y minus x. So, means, let's see the example. X is 15, y is 8. So, x minus y is 15 minus 8, 7. But y minus 8 is minus 7. Means 8 minus 15. We have seen in integers, subtraction of integers. So, 8 minus 15 is minus 7. So, 15 minus 8 is 7 and 8 minus 15 is minus 7. Means x minus y is not equal to y minus x. Means value of x and y you have to check. So, let's see this example. X is 0, y is 18. So, x minus y is 0 minus 18. Because value of x is 0 and value of y is 18. So 0 minus 18 is 18. If we do y minus x, y is 18 and x is 0. So 18 minus 0 is 18. So it is minus 18 and it is 18. So again we say that x minus y is not equal to y minus x. Associative property. For any three whole numbers x, y, z, x minus in bracket y minus z is not equal to x minus y in bracket minus z. Okay. So that is subtraction of whole number does not satisfy associativity, that is associative property. Means if we take value of x, y, z and if we substitute here, we will not get this equation is equal to this equation. It is clearly mentioned this equation is not equal to this equation. Okay, even if value of x, y, z is common in both the sides. So let us check that. For x is 15, y is 10 and z is 7. So x minus y minus z. So value of x is 15, value of y is 10, value of z is 7. So here it is. So 15, this 15, first we'll solve bracket. 10 minus 7 is 3. So 15 minus 3 is 12. Okay, let's see. Now this part, x minus y minus z, 15 minus 10, value of x is 15, y is 10 minus 7. So 15 minus 10 is 5 and minus 7 is minus 2. So we say that 12 and minus 2, they are not equal. So for any three whole numbers x, y, z, this equation is not equal to this equation. So associative property do not work here. Let us see the distributive property. For any three whole numbers x, y and z, x multiplied by y minus z is equal to, look, what it is done? A distributive property, very important property, x into bracket y minus z. So x, we have to open this bracket. So x into y, you can see x multiplied by y minus again x multiplied by z, x multiplied by z. Okay, so this is called distributive property. Okay, so this will see value of x, y and z. Let value of x be 1, y be, we'll see here x is 5, y is 2 and z is 10 suppose. So what is x? Value of x is 5 multiplied by y is 2 and z is 10, okay, which is equal to 2 minus 10 is minus 8. So I get minus 40. So my this equation is minus 40. So what I'll get for this equation? For this equation also I should get minus 40. So what is x? X is 5. So see, this is 5. Y is 2. This x is again 5 and z is 10. So 5 2s are 10 minus 5 10s are 50. So 10 minus 50 is minus 40. So this also 40 and this also minus 40 and this also minus 40. Okay, distributive property we will see in detail while solving examples. Okay, now fifth one, existence of identity for any whole number x. X minus 0 is x, but x 0 minus x is not equal to x. Means when I write 5 minus 0, I will get 5. But 0 minus 5, I will get minus 5. Means 5 x minus 0 is not equal to 0 minus x. Okay. Yeah, same. Thus for subtraction, no identity number exists. It existed for addition, right? X plus 0 is equal to x. And 0 plus x is equal to also x. So, existence of inverse. Since subtraction for every non-zero whole number does not have identity number, its inverse does not exist. See, subtraction. Since subtraction for every non-zero whole number does not have identity number. Since this is not possible, so this is also not, inverse is also not possible. So existence of identity is not possible for subtraction. So existence of inverse is also not possible. All right. So we have seen few properties and we'll see the exercise. Only few questions are there in the exercise. Let us see. Exercise 5b. Consider two whole numbers a, b such that a is greater than b. Now here we have to consider two whole numbers a and b, where a should be greater than b. Then you have to find out is a minus b a whole number, is this result always true? And is b minus a whole number, is this result always true? We will see one by one. Okay. So what is given is, consider two whole numbers a and b such that a is greater than b. So a is greater than b. It is given. Okay. So first question is a minus b a whole number? So let us see. Let a is 5 and let b be 3. This is assumption which we have done. Why a's value is greater? Because it is clearly mentioned in the question that a is greater than b. So what is a? A is 5 and b is 3. So I have taken a greater than b. Okay. So what we have to do is a minus b a whole number. Let us check. A minus b means 5 minus 3, because value of a is 5 and value of b is minus 3. 3, not minus 3. So 5 minus 3, that is a minus b is 2. 5 minus 3 is 2, which is a whole number. Okay. Then let us take another example. A minus b, I have taken a is 6 and b in 2 here. A is greater than 2, b. So 6 minus 2 is 4, which is a whole number again. See, we have proved in 1, second and third also we will be proving. Again, third example we have taken. A minus b is 10 minus 5, which is 5. Value of a is 10, which is greater than value of b, which is 5. So in this three cases, a minus b, a minus b, a minus b, all the three numbers came, the result came to be a whole number where we kept a greater than b. So answer here is yes, this result is always true. We have tried 3 times, the result has come whole number. Let us see the second. Is b minus a whole number? Is this result always true? Now opposite. Opposite means we have to keep A greater number and B smaller number. That is true. So B minus A is 2 minus 5. Substitute the value. What is B is 2 and what is A is 5. So 2 minus 5 is minus 3. And you know, since it is negative integer, it's not a whole number. So which is not a whole number. So B minus A is 10 minus 15. So now next example, we have taken A is 15 and B is 10. So 10 minus 15 is minus 5. Substitute value of B and A here, which is again not a whole number. Next is B minus A is equal to 7 minus 10. We have value of B is 7 and value of A is 10. According to the given condition, the value of A should be greater than value of B. So 7 minus 10 is minus 3, which is again not a whole number. So we have tried 3 times. In this, the results were same. Yes, this result is always true. Okay. Now let's see. Now question number 2 we are cancelled. 3 is cancelled. 4 is also cancelled. Now see question number 5. 12 multiplied by 9 minus 6. 12 multiplied by 9 minus 6. So what is 12? 12 we have kept. 12 we have kept. So 12 here multiplied by 9 minus 6, 3. So 12 3s are 36. Okay. Now here we can see we have here bracket is opened, you can see 12 multiplied by 9 minus 12 multiplied by 6. So here we are following distributive property. 12 multiplied by 9 minus 12 multiplied by 6, which is equal to, now 12 9s are 108 minus 12 6 are 72. So 108 minus 72 is 36. So both the sides we get the same answer, 36, 36. Now, is 12 multiplied by 9 minus 6 is equal to 12 multiplied by 9 minus 12 multiplied by 6? Means see, is this is equal to this? Here this is equal to 36. This is equal to 36. So the answer is yes. See, this equation is this and this equation is this. Are they same? Yes, they are same. Is this type of result always true? Yes, this type of result will be always true. Name the property used here. The property used here is distributivity property, or we can say distributive property. Now, same question number 6 is homework. You have to do it in textbook. Okay. Question number 1 you are supposed to do in notebook. Rest question number 5 and 6 you can do in the textbook. Okay. So commutative next video we'll be seeing all the properties for multiplication. Okay, this segment is very important. Okay, so thank you so much and please take care.